Good evening, ladies and gentlemen. So today we have been faced with one interesting discussion under functions, that is verifying if a function is even, odd, or neither. So we have been told to say we should verify whether each of the given function is even, odd, or neither. So when we are told to verify if a function is even, odd, or neither, this is the expression that we always use. So now that we know the basic fact that this is the expression that is always used, then what is the myth behind this? So when you replace this function in every function you get, and if that function resembles the original function, then the function is even. So if we are to replace this and our function still resembles f of x, then this function is what is referred to as even. But if you were to replace this negative x into a function and does not resemble but resembles it when you multiply it with a negative, then it is odd. So these are the basic rules behind even, odd, and neither. So the first function we have been given is x to the power 4, where you know the fact that if you were to replace negative x into x to the power 4, you still get the same result. So this function is even. Then if you were to get the same negative x, you put it in b, where you know to say the function of b is f of x is equal to x squared plus 1. So f of negative x is equal to negative x squared plus 1. So this basically gives you x squared plus 1. So this function is still even. The third example we have is reading f of x is equal to x to the power 4 plus 2x squared. So we get our f of negative x. We put it on x. So we have negative x to the power 4 plus 2 negative x squared. You know for sure that negative x to the power 4 is still x to the power 4. And negative x squared is still 2x squared. So this function resembles the very same function which we have in our preamble there. So this function is still even. So this one is still even as well. Then the fourth one we have is simply f of x is equal to x to the power 3 plus 2x squared. So we do the same. So you get the very same rule we have been given. So negative x. So we also put here plus 2 negative x. Then from here we know for sure that negative x to the power 3 is still negative x to the power 3. Then negative x squared is 2x squared, like that. So we know that this function now does not resemble this one. So it is not what? It is not even. So if it is not even, let us try if it is odd. So we multiply this by a negative. So this times that gives us x to the power 3. Then we have negative times that gives us negative 2x squared. So this function as well is not equal to that one. So this one is neither even nor odd. So lastly, we have been given the function of f of x is equal to x squared plus 2x minus 3. So if you have understood what we have explained, you can pause the video and try to work out this very question. So now we just replace with our negative x. So we say negative x squared plus 2 negative x minus 3. So we know for sure that this is the same as x squared minus 2x minus 3. We know that this is not equal to that, so it is not even. So if it is odd, let us multiply it. We see, we multiply with the negative to see if it's odd. So this times that is negative x squared This times that is simply positive 2x and positive 3. So this has happened when we have multiplied this with a negative. So is this equal to that still? No, it's not. So it is neither odd nor even. So if you have any question, you can drop it in the comment section. We know how to help you. So this is how basically you prove if a function is even, odd, or neither. Your host, Golden Zulu.